July 14th, 1941. Outside Dubno, Ukraine, the shell hits at 9:23 a.m. It punches through the turret of the KV-1 heavy tank like a nail through tin, and the sound is sharp, metallic, final. Inside, there's no time to scream. The crew is gone before the smoke clears. 20 meters away, Lieutenant Dmitry Lavrenenko watches from his own tank, a BT-7, and knows his machine won't last any longer. The German Panzer IV that just killed his comrade swivels its gun. Lavrenenko can see the barrel, dark and patient, searching. He orders reverse. The engine screams. They back into a tree line, but it doesn't matter. 3 more Soviet tanks are burning now. Black smoke rolls across the wheat fields, and you can smell burning oil, scorched paint, something worse. The Germans have better optics, better guns, better tactics, and their armor, sloped and confident, shrugs off most of what the Soviets throw at it. This is the problem. Not just here, not just today. Everywhere along the Eastern Front, Soviet tanks are dying faster than they can be built. The Red Army has numbers, courage, a willingness to bleed, but steel matters, thickness matters, angle matters. And right now, Soviet armor is a death sentence. By noon, Lavrenenko's unit has lost 11 tanks. He survives because he's smart, because he's lucky, because the Germans decide to consolidate their position instead of pursuing. That night, back behind the lines, he sits with his remaining crew and stares at a dented helmet someone pulled from a wreck. There's a hole through the front. Clean. Precise. "We need better tanks," someone says. Lavrenenko nods. Everyone nods. But nobody knows how to make it happen. The factories are already running day and night. Steel is rationed. Germany controls half of Europe's industrial capacity, and the Soviets are barely holding the line. You can't just wish better armor into existence. You can't just draw it on paper and hope it appears. But someone, somewhere, is already thinking about it. Not a general, not a committee. A man who learned his trade shaping horseshoes and hammer welding plowshares in a village forge. A man who understands that steel has a memory, that heat changes everything, that sometimes the answer isn't more material, but smarter material. His name is Alexander Morozov, and he's about to solve a problem that has stumped Soviet high command, German intelligence, and every Allied observer who watches Soviet tanks burn by the hundreds. He's going to do it with railroad tracks. Not new ones, not specially forged high-quality alloy plates shipped from distant smelters. Old ones. Torn up from abandoned lines, scavenged from bombed-out rail yards, pulled from sidings that lead nowhere anymore. Steel that was meant to carry freight trains, not stop armor-piercing rounds. Steel that most engineers would dismiss as scrap. But Morozov sees something else. He sees abundance. He sees a material already distributed across the entire Soviet Union, sitting in every town with a real connection. He sees steel that's been work-hardened by 1,000,000 tons of rolling weight. Steel that's cheap, available, replaceable. And more than that, he sees geometry. Not thicker armor, smarter armor. Because the secret isn't just what you use, it's how you use it. Right now, in the summer of 1941, Soviet tanks are built with vertical armor plates, or close to it, straight up and down, like walls. When a German shell hits, it strikes perpendicular, full force, and punches through with brutal efficiency. The Germans know this. They've optimized their guns for exactly this kind of target. Flat, predictable, penetratable. Morozov is about to change the equation. He's going to tilt the armor, 60 degrees from vertical. Not a little, a lot. Enough that when a shell hits, it doesn't meet resistance head-on, it glances, it skids, it loses energy against a surface that refuses to be hit square. The effective thickness doubles, triples, without adding a single kilogram of extra steel. It's physics, it's elegance, it's the kind of idea that makes you wonder why no one thought of it sooner. Except, people did think of it. French designers played with sloped armor in the 1930s, so did the Americans, but they couldn't make it work in production, couldn't solve the engineering problems, couldn't commit to the radical redesign it required. Morozov doesn't have the luxury of caution. The Soviet Union is losing the war. Factories are being evacuated, cities are falling, and the only thing standing between Moscow and the Wehrmacht is time, space, and a willingness to try something desperate. So he tries. And in a cramped office in Kharkiv, surrounded by blueprints and cigarette smoke, Alexander Morozov begins sketching a tank that will stop tigers. Alexander Morozov is 36 years old in 1941, and he doesn't look like a man who's about to revolutionize armored warfare. He's compact, quiet, with hands that still carry the calluses from his early years at the forge. Born in 1904 in the village of Kharkiv, he grew up in a world of coal fires and iron, where metal was shaped by patience and repetition, where you learned to read steel by the color it turned under heat. His father was a blacksmith. So was his grandfather. Morozov was supposed to follow the same path, hammering out horseshoes and cart axles for farmers who paid in bread and potatoes. But he was curious. He read, he studied, and when the revolution came, it opened doors that had been locked for centuries. By 1928, he was enrolled in the Kharkiv Technological Institute, studying mechanical engineering alongside the sons of party officials and factory managers. He never forgot the forge, though. That's the part people miss when they talk about the T-34. They focus on the design, the specs, the battlefield performance, but they skip over the fact that Morozov understood steel in a way that most engineers didn't. He knew what happened when you heated it, cooled it, bent it, welded it. He knew that different steels had different personalities, that some would crack under stress while others would flex, that the quality of a weld mattered as much as the thickness of the plate. And he knew that if you couldn't get perfect steel, you used what you had and made it work. By 1936, Morozov is working at the Kharkiv locomotive factory, which has been repurposed for tank production. The Soviet Union is building armor fast, quantity over quality, trying to match the growing mechanized forces of Germany and Japan. Morozov is part of a design team working on the BT series, fast tanks with Christie suspension, light armor, decent mobility. They're not bad, but they're not good enough. He sees the reports from Spain where Soviet tanks are fighting in the Civil War. He reads about tanks burning, crews abandoning vehicles after a single hit, armor that might as well be paper against modern anti-tank guns. The numbers are ugly. The conclusions are clear. Vertical armor is a dead end. So he starts sketching. Not officially, not as part of any sanctioned project, just late at night, after the other engineers have gone home, when the factory floor is quiet except for the hum of distant machinery. He draws tanks with sloped hulls, angled turrets, designs that look strange, almost alien compared to the boxy Soviet machines rolling off the line. His colleagues think he's wasting time. You can't weld plates at that angle, one tells him. The seams will be weak. The interior space will be too cramped. Where do you put the crew? And even if you build it, where do you get the steel? We're already rationing armor plate. Morozov listens. He nods. He doesn't argue, but he keeps sketching because he's already solved the steel problem in his head. Railroad tracks. The Soviet Union has over 100,000 kilometers of rail line. Some of it is active, hauling troops and supplies to the front. Some of it is abandoned, left over from the Tsarist era, connecting towns that don't exist anymore. Some of it is in the path of the German advance, about to be overrun, destroyed, rendered useless. And all of it is made from high carbon steel, hardened by years of use, tough enough to support locomotives weighing hundreds of tons. It's not armor grade steel. It's not homogeneous. It's not what any textbook would recommend for tank construction.
But it's everywhere. And if you slope it at 60 degrees, if you make the shell hit at an angle instead of straight on, if you force the projectile to travel through more material before it reaches the crew, then suddenly railroad steel becomes armor steel. Not because the material changed, because the geometry changed. Morozov does the math. He calculates penetration angles, impact velocities, the effective thickness of a 45mm plate sloped at 60 degrees. The numbers are startling. A thin, sloped plate can stop rounds that would punch through twice the thickness of vertical armor. It's counterintuitive. It feels wrong. But the physics is undeniable. He takes his sketches to Mikhail Kushkin, the chief designer at the Kharkiv factory. Kushkin is older, more experienced, more politically connected. He's also dying, slowly, from pneumonia he caught during a winter test drive in 1940. But he's still sharp, still ambitious, still willing to gamble on a radical idea if it might save Soviet lives. Kushkin looks at the drawings for a long time. "This will be expensive to retool," he says finally. "Less expensive than losing the war," Morozov replies. Kushkin almost smiles. "And you think we can use railroad steel?" "I think we don't have a choice." There's a pause. Outside, the factory is hammering, welding, assembling tanks that will be obsolete before they reach the front. Kushkin taps the drawings with one finger, thinking. Show me a prototype. Not a full tank, just the hull. Prove the welds will hold. Prove the steel will work. If you can do that, I'll take it to Moscow. Morozov doesn't waste time. Within a week, he has a section of hull plate cut from recycled rail steel, welded at a 60-degree angle mounted on a test frame. It's rough, unfinished, ugly, but it's real. They take it to the proving ground outside Kharkiv. A small crew, no officials, no observers, just engineers who want to see if this crazy idea has any merit. They set up the plate at 50 meters and load an anti-tank rifle, the PTRD-41, the kind of weapon Soviet infantry uses to try and stop German tanks. It fires a 14.5mm armor-piercing round, and at this range it can punch through most Soviet tank armor. Morozov stands behind the firing line, arms crossed, face blank. The rifle cracks. The round hits the sloped plate with a sound like a hammer on an anvil, and sparks fly. When the smoke clears, there's a dent, a gouge, but no penetration. The round glanced off. Deflected by the angle, its energy scattered across the surface instead of focused into a single point. They fire again. Same result. Again. Again. By the sixth shot, the plate is scarred and battered, but still intact. No holes, no cracks. The welds held, the steel held, the geometry worked. One of the engineers, a man named Kucherenko, walks up to the plate and runs his hand over the impact marks. He looks back at Morozov, and there's something like awe in his expression. You just made thin armor better than thick armor, he says quietly. Morozov shrugs. I made cheap armor better than expensive armor. That's what matters. Kushkin takes the results to Moscow in early 1940. He presents the design to a committee of military officials, factory directors, and Communist Party representatives. Most of them are skeptical. Some are hostile. Sloped armor is untested. Railroad steel is unorthodox. The whole concept feels like a gamble, and the Soviet Union doesn't have resources to waste on gambles. But one man listens. Marshal Klement Voroshilov, People's Commissar for Defense, sees the numbers and understands what they mean. He sees a design that can be built in any factory with access to a rail line. He sees armor that doesn't require rare alloys or specialized forges. He sees a tank that can be mass-produced, distributed, repaired in the field with scavenged materials. He approves production. The tank will be called the T-34, and by the time it reaches the battlefield, it will change everything. Production begins in June 1940, and immediately, everything goes wrong. The first problem is the factories. Soviet tank plans are set up for vertical armor assembly, flat plates, welded into box shapes, straightforward and fast. Now they're being asked to cut and join angled sections, compound curves, surfaces that meet at odd degrees. The welders hate it. The foremen hate it. The quality control inspectors hate it because half of the early welds crack under stress testing, splitting along seams that should have held. Morozov spends 3 weeks living in the Kharkiv factory, sleeping on a cot in the corner of the assembly hall, watching every step of the process. He's there when a welder named Petrov tries to join 2 sloped plates and the bead breaks, spilling molten metal across the floor. He's there when a foreman throws his clipboard down and says this whole design is impossible, that they should go back to building BT tanks, something people know how to make. Morozov doesn't argue. He picks up a welding torch himself. He's not supposed to do this. He's a designer, an engineer, management. But he knows how to weld. In his father's forge, back when he was 12 years old and barely strong enough to lift a hammer, he knows the rhythm of it, the way you have to move the torch, the sound the metal makes when the temperature is just right. He shows Petrov how to preheat the joint, how to angle the torch so the weld pool flows into the gap instead of sitting on top. He shows him how to move steadily, not too fast, not too slow, letting the steel fuse without burning through. It takes 20 minutes. When he's done, the seam is clean, strong, flawless. Petrov stares at it, then at Morozov, and there's something like awe in his expression. You just made thin armor better than thick armor, he says quietly. Morozov shrugs. I made cheap armor better than expensive armor. That's what matters. Word spreads. The designer who welds, the engineer who works with his hands. It changes something in the factory. Workers stop seeing the T-34 as an impossible task forced on them by bureaucrats in Moscow. They start seeing it as something they can actually build, one weld at a time, one tank at a time. By August, the first complete T-34 rolls off the line. It's not beautiful, the welds are rough in places, the paint is uneven, and the turret hatch sticks because the tolerances are still being worked out. But it's functional. It moves. The suspension handles rough ground better than anything the Soviets have built before. And the armor, that strange slanted armor made from recycled railroad steel, holds up under every test they throw at it. They take it to the Kubinka Proving Ground outside Moscow, where the military keeps a collection of captured German tanks for study. There's a Panzer III there, taken from a battlefield in Poland, its 50mm guns still functional. Soviet engineers have been using it to test their own armor, firing German rounds at Soviet plates to see what penetrates and what doesn't. Now they turn it on the T-34. The test crew sets the Panzer's gun at 100 meters, point-blank range by battlefield standards. They load an armor-piercing round, the same type that's been chewing through Soviet tanks since the invasion started. A small crowd gathers to watch, officers, engineers, factory representatives. Some of them are hoping the T-34 works. Some of them are hoping it fails, because failure means they can go back to building tanks they understand. The Panzer fires. The sound is flat and loud, like a door slamming in an empty room. The round hits the T-34's frontal armor, and you can see the impact. A bright flash, a spray of sparks. The tank rocks slightly on its suspension, smoke curls from the point of impact, then nothing. No penetration, no crack. The round deflected, skinning off the sloped plate and burying itself in the dirt 30 meters away. The crowd is silent. Someone walks up to the T-34 and runs his hand over the impact mark. There's a gouge, a scar, but the armor held. They fire again. Same result. A third time, the round deflects high, spinning through the air like a skipped stone. One of the officers, a colonel named Fedorenko, turns to Morozov. How thick is that plate? 45 millimeters, Morozov says.
And it's stopping 50mm AP rounds at 100 meters. Yes. Fedorenko nods slowly. What happens when they use bigger guns? We slope it steeper, Morozov replies, or we use thicker rail steel, or both. The colonel doesn't smile, but something in his expression shifts. He's seeing the same thing Morozov saw 2 years ago, back when this was just a sketch on paper. He's seeing a tank that can be built anywhere, armored with materials that are sitting in rail yards from Leningrad to Vladivostok, protected by geometry instead of rare alloys. He's seeing a way to win. But winning takes time, and time is something the Soviet Union doesn't have. By June 1941, only 1,200 T-34s have been built. That sounds like a lot until you realize the Red Army has over 20,000 tanks total, and most of them are obsolete, under-armored, under-gunned machines that won't last a week against the Wehrmacht. When Germany invades on June 22nd, the T-34s are scattered across a front that stretches from the Baltic to the Black Sea, too few to make a difference, too new for most crews to know how to use effectively. The tanks that do see combat, though, are a revelation. Near Ryseni in Lithuania, a single T-34 holds up an entire German division for 2 days. It sits at a crossroads, dug in, firing at anything that moves. German Panzer IIIs and IVs try to flank it, but their rounds bounce off. Anti-tank guns hit it 11 times, and 11 times the shells deflect or fail to penetrate. Finally, the Germans bring up engineers, who crawl close enough to plant demolition charges under the treads, immobilizing the tank. When they pry open the hatch, they find the crew dead, not from penetration but from concussion, the repeated impacts finally causing internal injuries. But the armor never broke. German tank crews start reporting encounters with Soviet tanks they can't kill. Intelligence officers interview prisoners, examine wreckage, try to understand what they're facing. The reports are consistent. Sloped armor. Thick, hard steel that doesn't behave like normal armor. Rounds that should penetrate just glance off. In Berlin, engineers at the Waffenamt, the weapons testing agency, get their hands on a captured T-34 in late 1941. They examine it for weeks, measuring angles, testing welds, analyzing the steel composition. What they find surprises them. The armor isn't special steel. It's not some advanced Soviet alloy. It's just high-carbon steel, work-hardened, inconsistent in quality, exactly what you'd get from recycled railroad tracks. By German standards, it's crude, unrefined, the kind of material they'd reject for tank production. But it works. One German engineer, a man named Kniepkamp, writes a report that circulates through the Wehrmacht's tank design offices. In it, he notes that the T-34's armor is not superior in material quality, but superior in application. He points out that the 60-degree slope effectively triples the armor's resistance to penetration, that the simplicity of the design allows for rapid production, and that the use of non-specialized steel means the Soviets can build these tanks anywhere. His conclusion is blunt. We are fighting a tank that should not be possible to produce in such quantities, yet it is being produced. We must adapt. The Germans do adapt. They start developing the Panther, a tank heavily influenced by the T-34's sloped armor. They upgun the Panzer IV, giving it a longer 75mm cannon that can penetrate the T-34 at range. And they rush the Tiger into production, a behemoth with an 88mm gun that can kill anything the Soviets have. But it's too late. By 1942, Soviet factories are producing T-34s faster than Germany can destroy them. The Kharkov plant has been evacuated east, beyond the reach of German bombers, and it's running 3 shifts, 24 hours a day. Workers are pulling rail steel from abandoned lines, melting it down, rolling it into plates, welding those plates into tanks. Factories in Nizhny Tagil, Omsk, and Chelyabinsk, places the Germans can't touch, are doing the same. Morozov's radical idea, his blacksmith's intuition about angles and geometry, has become the foundation of Soviet armored warfare. And on a cold morning in November 1942, outside Stalingrad, a T-34 commander named Dmitry Lavrenenko, the same man who watched his unit die at Dubno, will sit in a tank armored with railroad steel and face down a Tiger. He'll survive. The Tiger won't. The Ural Tank Factory number 183 sits in Nizhny Tagil, 1,400 kilometers east of Moscow, in a region so cold that in January the air freezes the moisture in your lungs. It's October 1941, and the factory is barely a factory. It's a collection of half-built structures, open to the sky in places, with machinery still being unloaded from railcars that arrived 3 days ago from Kharkov. The evacuation was chaos. When the Germans pushed toward Kharkov in September, the Soviet government ordered the tank plants dismantled and shipped east, beyond the range of the Wehrmacht, beyond the reach of the Luftwaffe. Workers disassembled production lines in the middle of the night, loaded presses and lathes and welding equipment onto flat cars, stripped entire buildings down to the foundation. They took everything: tools, blueprints, raw materials, even the light fixtures. And they took people. 15,000 workers, engineers, their families, everyone who knew how to build a T-34 were evacuated east. They traveled in unheated trains, packed into freight cars meant for cargo, not passengers. Children froze. Old people died, but they kept moving because staying meant capture, and capture meant the end of T-34 production. By the time they reach Nizhny Tagil, winter is coming and the factory is a shell. No roof on the main assembly hall, no heating, no proper housing for the workers who are sleeping in tents and unfinished barracks, burning whatever they can find to stay warm. But there's a rail line. It runs right through the center of town, connecting Nizhny Tagil to the rest of the Urals, to Siberia, to the vast industrial network that the Germans can't touch. And along that rail line, in sidings and depots and forgotten stretches of track, there's steel. Miles of it, tons of it. Old rails pulled up during track maintenance, damaged sections replaced and stacked in rail yards, reserves stockpiled for future expansion. Morozov, who made the journey east with the factory, sees it and knows they can keep building. He walks the rail line on his second day in Nizhny Tagil, his breath fogging in the cold air, his boots crunching on gravel. He stops at a siding where a pile of old rails sits rusting, half buried in weeds. He crouches down, runs his hand over the surface, feeling the texture, the pitting from years of weather. It's not pretty, but it's steel. He stands up and waves over a factory foreman, a man named Zaltzman, who made the evacuation with his wife and 2 daughters, all of them now living in a single room with no heat. "Can we cut these?" Morozov asks, nodding at the rails. Zaltzman looks at the pile, then at Morozov. "The rails?" "Yes." "For what?" "Tank armor." Zaltzman is quiet for a moment. Then he laughs, short and sharp. "You're serious?" "Completely. We don't have cutting equipment yet. Half the tools are still on trains somewhere between here and Kharkov. So we use what we have," Morozov says. "Torches, hammers, saws, whatever works." Zaltzman shakes his head, but he's smiling now. The kind of smile people wear when they realize they're about to do something impossible. You know how to motivate people, I'll give you that. By mid-October, the factory is producing tanks again. not many, not fast. The first T-34 to roll out of Nizhny Tagil is a Frankenstein machine, assembled from parts made in 3 different factories, welded together in an assembly hall with no roof, painted with whatever color was available because proper camouflage paint hasn't arrived. The armor is cut from rail steel pulled from a siding 2 kilometers away, heated in a makeshift forge, hammered into rough plates, welded at angles that still make the workers nervous. It's ugly, it's crude, but it runs. And more importantly, it works. They test fire it with a captured German anti-tank gun, a 37mm piece taken from a destroyed Panzer III. At 200 meters, the round hits the frontal armor and deflects, spinning off into the snow. They fire again, aiming for the turret. Same result. The rail steel, sloped at 60 degrees, does exactly what Morozov said it would do. The workers cheer. Not because the tank is perfect, because it proves they can do this, here, in the middle of nowhere, with almost nothing. By November, they're producing 5 tanks a day. By December, 10. By January 1942, 15. The pace is brutal. Workers pull 12-hour shifts, sometimes longer, sleeping in the factory when they're too exhausted to walk back to their barracks. Welders develop lung problems from the fumes because there's no proper ventilation in the assembly hall. Machinists lose fingers to equipment that's been reassembled poorly, bolted together in the dark, never properly tested. But they keep building because every tank that leaves the factory is one more tank on the front line, one more chance for a Soviet crew to survive contact with the Wehrmacht, one more piece of armor standing between the Germans and Moscow. Other factories are doing the same thing. In Chelyabinsk, in Omsk, in Sverdlovsk, wherever the rail lines reach, they're pulling up old track and turning it into T-34s. The process is the same everywhere. Cut the rails into sections, heat them until they're malleable, hammer or press them into plates, weld those plates at the angles Morozov specified, bolt on a turret, install an engine, mounted gun, and send it west. It's not elegant, it's not efficient by peacetime standards, but it's fast, and fast is what matters. A German intelligence report from February 1942 estimates that the Soviets are producing 1,200 tanks per month. The actual number is higher. By March, it's 1,500. By summer, over 2,000. The Wehrmacht is destroying Soviet tanks by the hundreds, but the replacements keep coming. Endless, relentless. Each one armored with steel that was carrying freight trains 6 months ago. The Germans can't match it. They try. Production of Panzer IIIs and IVs increases. The Tiger enters service, a technological marvel with an 88mm gun that can kill a T-34 at 1,000 meters. The Panther follows, with sloped armor copied directly from the T-34, an admission that Morozov's design was right all along. But Germany doesn't have 100,000 kilometers of rail line to cannibalize. They don't have factories in the Urals, safe from bombers, churning out tanks 24 hours a day. They don't have Morozov's insight that sometimes the answer isn't better steel, just smarter steel. By mid-1943, the balance has shifted. Soviet tank losses are still horrific. Crews still die. T-34s still burn when they're hit in the right place, when a Tiger catches them at long range, when an 88 punches through the turret or the side armor. But for every T-34 destroyed, 2 more are rolling off the production lines. And those tanks, armored with recycled rail steel, sloped at 60 degrees, are good enough. Not perfect, not invincible, but good enough. At Kursk in July 1943, the Wehrmacht throws everything it has into one last massive offensive. Nearly 3,000 tanks, including hundreds of Tigers and Panthers, the best armor Germany has ever produced. They meet a Soviet defense anchored by T-34s, dug in, waiting, their sloped armor ready. The battle lasts 2 weeks. When it's over, the Germans have lost 760 tanks and the offensive is broken. The T-34s took horrific losses too, over 1,600 destroyed, but the Soviets can replace them. Germany cannot. From Kursk forward, the Wehrmacht is retreating, and every kilometer they give up, the Soviets are there, pushing forward in tanks made from railroad steel, driven by crews who know that their armor, for all its flaws, is the reason they're still alive. Morozov never sees Kursk. He's back in Nizhny Tagil, working on the next generation of the design, refining angles, improving the turret, making the T-34 better with every iteration. He sleeps 4 hours a night. He eats at his desk. He's lost weight, developed a cough that won't go away, aged 10 years in 2. But when he gets reports from the front, when he reads about T-34s holding the line, stopping Tigers, surviving battles they shouldn't survive, he knows it was worth it. One evening in August 1943, he's sitting in his office staring at a blue punt when Zaltzman walks in. The foreman looks tired, older, but there's something light in his expression. "We just hit 20,000 tanks," Zaltzman says quietly. "Total production. all factories combined. Morozov looks up. 20,000. 20,000, Zaltzman repeats. Made from rail steel. Just like you said. Morozov leans back in his chair. He doesn't smile, doesn't celebrate. He just nods once and turns back to his blueprints. There's still work to do. February 19th, 1943, outside Kharkiv, Ukraine. The Tiger tank sits at the edge of a frozen field, its commander scanning the tree line through his periscope. His name is Oberlieutenant Klaus Becker, and he's been in this war since Poland. 4 years of combat that have taught him to trust his machine. The Tiger is 56 tons of German engineering, armored with 100 millimeters of face-hardened steel on the front, armed with an 88 millimeter gun that can kill anything the Soviets field at ranges they can't even return fire from. He's already knocked out 3 T-34s this morning, all at over 800 meters. Clean kills, one shot each, punching through that sloped armor like it wasn't there. But at 10:15 a.m., something feels different. 4 more T-34s are moving across the field, low and fast, using the terrain, keeping their frontal armor toward him. They're not retreating, they're maneuvering, and they're getting closer. Becker orders his gunner to fire. The 88 roars, and the lead T-34 takes the hit on its front glacis. Sparks fly, the tank shudders, but it doesn't stop. The round deflected, skating off the 60-degree armor, and the T-34 keeps coming. His gunner fires again. Another hit, another deflection. What the hell, the gunner mutters. Becker understands the problem immediately. At long range, the 88 has enough velocity to punch through the T-34 sloped armor, hitting it almost perpendicular despite the angle. But as the range closes, as the Soviet tanks get nearer, the angle becomes more extreme. The shells are hitting at sharper deflections, losing penetration, skipping off instead of biting in. The T-34s are inside 400 meters now. One of them fires. The 76 millimeter round hits the Tiger's frontal armor and bounces off, but the message is clear. They're in range now, and there are 4 of them. Becker makes a decision he never thought he'd have to make in a Tiger. He orders his driver to reverse, to open the range again, to get back to a distance where his gun's velocity can overcome that damned sloped armor. The Tiger backs up, its engine roaring, tracks chewing frozen earth. The T-34s press forward. It's a reversal of everything the Tiger was designed for. This tank is supposed to sit at range and dominate. It's supposed to kill enemy armor before they can even threaten it. But Morozov's geometry has changed the equation. At 600 meters, Becker's gunner finds his mark. A T-34 takes a round through the turret ring, where the armor is thinner, where the angle doesn't help. It stops, smoke pouring from the hatches. The other 3 scatter, moving unpredictably, making themselves hard targets. One of them gets close enough to fire again. The 76 millimeter round hits the Tiger's side armor, and this time it penetrates. Not deep, not enough to kill the tank, but it punches through, spalling metal fragments inside the crew compartment. Becker's radio operator screams, clutching his leg where a piece of shrapnel has torn through his calf. The Tiger kills 2 more T-34s before the last one retreats, disappearing into a ravine, trailing smoke, but still mobile. When it's over, Becker climbs out of his tank and walks over to examine the hits. There are 3 impact marks on his frontal armor, deep gouges where T-34 rounds struck but failed to penetrate. But there's also that hole in the side, clean and round, and he knows that if the Soviet tank had been a little more accurate, a little luckier, this fight could have ended differently. He lights a cigarette and stares at the burning T-34s. 3 kills, 1 damaged. A respectable morning by any standard. But it took more ammunition than it should have, more time than it should have, and for the first time since he climbed into a Tiger, he felt like he was fighting an opponent that could hurt him.
This is happening all across the Eastern Front. Tiger crews, Panther crews, even upgraded Panzer IVs with long 75mm guns are discovering that the T-34 is harder to kill than the specifications suggest. On paper, their guns should penetrate at reasonable ranges. In practice, those sloped plates are deflecting shots that should be kills, forcing German tanks to maneuver for side shots, to close range or extend it, to work harder for every victory. And the T-34s keep coming. For every one destroyed, there are 2 more behind it, 3 more, 5 more. Soviet tank production is a flood, and the Germans are drowning in it. By late 1943, Wehrmacht intelligence estimates that the Soviets are fielding over 10,000 T-34s. The actual number is higher and climbing. German tank commanders start calling them in Ratten Creek, Rat War. Not because the T-34 is weak, but because it's everywhere, overwhelming, impossible to eliminate. You kill one, and 10 more appear. You break through a formation, and another one is waiting behind it. The Tiger's still a better tank, technically. So is the Panther. Better optics, better gun, better crew ergonomics, better quality control. but there are only 1,347 Tigers ever built. The Soviets produced more than 57,000 T-34s before the war ends. Quantity has a quality all its own. In July 1943, at Prokhorovka during the Battle of Kursk, a German tank commander named Karl Schumann watches over 200 Soviet tanks charge his position. His unit has 18 Panthers, top-of-the-line machines with sloped armor copied from the T-34, armed with high-velocity 75mm guns that can penetrate anything the Soviets have. They destroy 47 T-34s in 2 hours. But the Soviets keep attacking. Waves of them, coming through the smoke and fire, some burning, some damaged, all pressing forward. The Panthers run low on ammunition, they overheat. Mechanical failures start hitting the new tanks, transmissions breaking, engines seizing. By the end of the day, Schumann has lost 11 Panthers. Not all the enemy fire. Some just stopped working, victims of rushed production and untested systems. The T-34s, crude and simple, kept running. That's the other part of Morozov's genius, the part that doesn't show up in armor penetration tables or ballistic tests. He didn't just design armor that worked, he designed a tank that could be built by workers with minimal training, repaired in the field with basic tools, kept running on terrible fuel and poor maintenance. The transmission is simple. The engine is a diesel, reliable and hard to kill. The tracks are wide, spreading weight, letting the tank move through mud and snow that would bog down a Tiger. And the armor, that railroad steel sloped at 60 degrees, doesn't require specialized knowledge to replace. If a plate gets damaged, you can cut a new one from any rail line, any factory with a torch and a hammer. German tanks are precision instruments. The T-34 is a weapon. There's a story, probably apocryphal, but repeated enough that it's entered Soviet legend, about a T-34 crew near Smolensk in 1944. Their tank takes a hit that damages the transmission. They're behind enemy lines, no way to call for recovery, no spare parts, no support. So they find an abandoned rail siding, cut a section of track, and use it to fabricate a makeshift repair. It holds long enough for them to drive 30 kilometers back to Soviet lines. Whether the story is true doesn't matter. What matters is that people believe it could be true, because that's the kind of tank the T-34 is. By 1944, the Germans have stopped trying to match Soviet production. They can't. Their factories are being bombed, their resources are stretched across two fronts, their fuel supplies are dwindling. Instead, they focus on quality, on bigger guns and thicker armor, on Tigers and Panthers, and eventually the monstrous King Tiger, a 70-ton behemoth that can kill a T-34 at 2,000 meters. But there are only 489 King Tigers built, and they're so heavy, so complex, so fuel-hungry that they spend more time broken down than fighting. The T-34s just keep rolling. At the Silo Heights in April 1945, the final major defensive position before Berlin, German forces dig in with every tank they have left. Tigers, Panthers, dug-in assault guns, anti-tank positions layered 3 deep. They face a Soviet assault force that includes over 900 T-34s. The Germans inflict brutal casualties. Hundreds of T-34s are destroyed in the first 2 days. But the Soviets don't stop. They push through, over, around, accepting losses that would break any other army because they know the factories in the Urals are still running, still producing, still turning railroad steel into armor. On April 16th at 3 a.m., a T-34 commanded by Anatoly Kozlov is the first Soviet tank to break through the German lines. His tank has been hit 4 times. 1 track is damaged. The engine is running rough, but the sloped frontal armor, that Morozov-designed geometry forged from recycled rail steel, held against everything the Germans threw at it. He will drive that tank all the way to Berlin. And when he gets there, when he climbs out and looks back at the armor that kept him alive, he'll run his hand over the scarred, battered surface and think about the blacksmith who made it possible. Morozov survives the war, not unscathed. He's 41 years old in May 1945, but he looks 60. The years of 16-hour days, sleeping in factories, breathing welding fumes, living on black bread and weak tea have hollowed him out. He has a chronic cough that never quite goes away, a tremor in his left hand from exhaustion, gray hair that wasn't there in 1941. But he's alive. And so are tens of thousands of Soviet tank crews who shouldn't be, who rolled into battle in machines armored with his geometry, his understanding of angles and deflection, his blacksmith's intuition about how steel behaves under stress. The final production numbers are staggering. Over 84,000 T-34s in total, all variants combined, built between 1940 and 1945. Not all of them used railroad steel. As the war progressed and Soviet industry stabilized, proper armor plate became more available. But in the desperate years, 1941 through 1943, when the outcome hung in balance, when every tank mattered, It was recycled rail steel that kept the production lines running. Morozov doesn't rest after the war. He's appointed chief designer of the Kharkiv Design Bureau, tasked with developing the next generation of Soviet tanks. He takes the lessons of the T-34 and pushes them further. Steeper angles, better armor composition, more efficient production methods. In 1947, he completes the design for the T-54, a tank that will become the most produced tank in history, with over 100,000 built across multiple decades and countries. It keeps the sloped armor philosophy, the same 60-degree geometry that made the T-34 work, refined and perfected. Every modern tank in the world, from the American M1 Abrams to the German Leopard to the British Challenger, uses sloped armor. It's so fundamental to tank design now that it's hard to imagine a time when it was radical, when engineers thought vertical armor was the only practical option. But there was that time, and one man changed it. The Western Allies notice. During the war, American and British intelligence officers examined captured T-34s, measuring angles, analyzing the steel, trying to understand how the Soviets are producing such effective armor in such quantities. The reports are mixed. Some praise the design, others dismiss it as crude, noting the poor crew ergonomics, the rough welds, the lack of sophisticated fire control systems, but they all acknowledge the armor works. American tank designers start experimenting with sloped plates in 1943, incorporating lessons from the T-34 into designs like the M26 Pershing. British engineers do the same, though their efforts are hampered by doctrinal resistance and resource constraints. By the end of the war, sloped armor is becoming standard practice across all major tank-producing nations. Morozov never gets the international recognition he deserves during his lifetime. The Soviet Union doesn't publicize its weapons designers, doesn't celebrate them the way it celebrates generals and political leaders. His name appears in technical journals and classified reports, in design bureaus where engineers know the history of their profession. But to the general public, even in the Soviet Union, he remains obscure. He dies in 1979 at the age of 75 from complications related to pneumonia.
His funeral is attended by colleagues, by military officials who understand what he contributed, by a few surviving tank crews who drove T-34s and lived to tell about it. There's a small memorial in Kharkiv, a plaque on a building that used to be part of the tank factory. It mentions his name, his role as chief designer, the T-34 and T-54. It doesn't mention the railroad steel, the desperate innovation born from necessity, the blacksmith's instinct that saved a nation. But the legacy is there, in every tank that rolls off a production line anywhere in the world. There's a broader lesson in Morozov's story, something that transcends tanks and armor and the specifics of World War II. It's about constraints breeding innovation, about necessity forcing solutions that comfort would never discover, about expertise developed in one context, the village forged the practical knowledge of how metal behaves, proving valuable in another. Morozov wasn't trained to revolutionize armored warfare. He was trained to shoe horses and fix plows. But he understood materials, understood stress and heat and angle, and when the war demanded an impossible solution, he provided one. Not with exotic alloys, not with advanced technology, with railroad tracks and geometry. The German engineers who examined captured T-34s were right to be impressed, but some of them missed the point. They saw the sloped armor and tried to copy it, building Panthers with similar angles, similar protection schemes, but they kept using specialized armor steel, kept relying on centralized production, kept designing tanks that required precision manufacturing and rare materials. They copied the geometry, but missed the philosophy. Morozov's real innovation wasn't just the 60-degree slope. It was understanding that in total war, the tank you can build 50,000 of is better than the tank you can only build 500 of, no matter how superior those 500 are on paper. It was recognizing that steel is steel, that railroad tracks hardened by years of use are harder than most people realize, that abundance matters more than purity. It was thinking like a blacksmith, not an engineer. In the decades after the war, as military historians and researchers dig deeper into Soviet archives, the details of T-34 production emerge. Stories of factories evacuated overnight, of workers sleeping in unheated buildings, of railroad steel being cut and welded into armor plates by people who learned the process that same week. One researcher, a British historian named Antony Beevor, interviews a Soviet factory worker in the 1990s, a woman named Nadezhda who worked at the Nijia Tagil plant during the war. She was 19 years old in 1942, assigned to a crew that cut rail sections into plates. "We worked 12 hours a day, sometimes more. The cold was terrible.
We didn't have proper clothes. Some girls lost fingers to frostbite, but we kept working because we knew every tank we made was one more chance for our boys to survive. Beevor asks her if she knew the armor was made from railroad tracks. She laughs. Of course we knew. We were cutting up the rails ourselves. It seemed crazy at first, but then we heard stories from the front about tanks that got hit, and the crew lived, and we understood. The designer, Morozov, he figured out something everyone else missed. What was that, Beevor asks. She thinks for a moment. You don't need the best steel. You just need enough steel in the right shape, in the right place. Everything else is details. It's as good a summary of Morozov's philosophy as any engineer ever wrote. Today, if you visit the Russian Tank Museum in Kubinka, you can see T-34s from different production periods, different factories, different years. Some are beautifully preserved, restored to museum quality. Others are left as they were found, scarred, battered, showing the wear of combat. If you look closely at the armor on the earlier models, the ones from 1941 and 1942, you can sometimes see the grain structure of the steel, the patterns that suggest it was forged for one purpose and repurposed for another. Not all of them, but some. Those are the tanks made from railroad tracks. They're the ones that held the line when the line couldn't afford to break. They're the ones that stopped Tigers, that pushed through to Berlin, that kept the Soviet Union in the war long enough for numbers and production to tip the balance. They're the legacy of a blacksmith who understood that sometimes the answer isn't making things perfect, it's making things work. Alexander Morozov never saw himself as a revolutionary. He was solving a problem, using the tools and materials available, applying lessons learned in his father's forge to the largest mechanized conflict in human history. He didn't set out to change tank design forever, he just wanted to keep Soviet crews alive. And in doing that, in taking railroad steel and sloping it at 60 degrees, he changed everything.